All right, my final information for you for the Unit 1 exam, this should be the 4th video that you watch, is first of all, a lot of the information has to do with the scientific method and how we understand science in the natural world. So one of the best things that you can do is to go back into your overview and reread this chapter on science in the natural world. This is found on ck12.org. If you'd like additional resources, you can go on ck12. There's a few videos, there's quizzes and things like that. You don't need a login. Do use your Google ID to sign yourself in. You don't need like a passcode or anything like that. You can just like search for science in the natural world and this information will come up. But we did read these in class. Your job was to highlight and kind of annotate as you read. But the bulk of your exam has to do with scientific thinking, inquiry, scientific method, laboratory design, goals of science, a lot of the stuff that's in this reading. So it's really important for you to have a good understanding of scientific inquiry, experimental design, why it's important to communicate your results in science. So this reading is going to be really valuable to you. It's what we've been talking about in class so far this week, and I think you're going to do great if you've kind of followed along with everything. The other bit of advice is to look over the Simpsons Experimental Design Worksheet. As I told you, there is an answer key online. If you Google Simpsons Experimental Design Worksheet answer key. We went over this one together in class, and I felt like you had a pretty good understanding of everything. But if you're still unclear about a few things, do take a time to look up that answer key and get yourself some more information. Lastly, what I'd like to do to help you be super prepared for the Unit 1 exam is I'd like to go over a few sample questions. Now, your test is going to be on Schoology, so it's not going to be on paper, but basically we copied these paper questions into Schoology. So, question number 1 that we're going to go over is, which of the following could be used by a student to better understand scientific principles and concepts? The choices here are mathematical models, physical evidence, computational tools, or all of the above. The best answer here is all of the above. Because if you remember the definition of inquiry, it's diverse ways scientists study the natural world, and all of these can be used to help scientists study the natural world. So all of these is going to be our best answer here. Another question to take a look at is, scientific explanations must always be based on blank. Opinion? No. Creativity? Not necessarily, no. Mathematics, you might be inclined to be like, yeah, math and science go hand in hand, and you might want to just like pick this as an answer. But if you carry on to D, the word evidence is going to be our best choice. And sometimes that's what you're really looking for in these exams, and especially when we take the Keystone exam, sometimes there might be an answer that if you really kind of flex your brain, it makes sense to you. But if you continue reading through all of the choices, you'll see that there's a better answer. I encourage you to use scrap paper while you're taking your test, because if you're like me, it helps you to make little notes and little messages to myself as I'm taking the test. So please feel free to use scrap paper. All right. Next question we're going to take a look at is number 3 here. A scientific theory is best defined as a universal truth that does not need scientific evidence to support it. We don't say words like this in science class. We don't say words like truth, or I can prove it, or that's a fact. You know, we keep ourselves open-minded. And everything should have scientific evidence to support it if you're thinking like a scientist. So A is definitely not the answer. We're going to skip down to C for a second. An educated guess about how a scientific phenomenon works. This is our old-fashioned elementary definition of a hypothesis. What's a hypothesis? It's an educated guess. We're too old for that now. We don't really use that type of language anymore. Letter D A testable statement that suggests an explanation for scientific phenomenon. That's a more academic definition of the word hypothesis. That's what we go with. But it's still not the answer to this question, which is asking us about a scientific theory, which brings us to B. A widely accepted explanation for a scientific phenomenon that is supported by extensive amounts of data. Yes. Theory. Best choice there. All right, another one I wanted to take a look at with you, just because I thought it could be a little bit tricky. All right, since the beginning of time, man has always wondered about the origin of life. Formerly, people believed in spontaneous generation, or the theory that life could arise from non-living matter. In 1668, a scientist named Francisco Redi disproved spontaneous generation by performing an experiment which concluded that maggots are not found in meat where flies are prevented from laying eggs. This experiment shows that. So, Francisco Redi's experiment disproved spontaneous generation because people used to think that maggots came from decaying meat. Because wherever there was decaying meat, there were flies and maggots around. So people were like, flies come from decaying meat. And Francisco Redi was like, that doesn't really make sense. I think flies come from other flies. So he covered the meat so flies couldn't get in, and voila, there were no maggots on the meat that was covered. So the choice is here. All scientific explanations are useful because nothing in the world are useless because nothing in the world is definite. That's kind of not a really good answer. All scientific explanations are definite and cannot be changed regardless of experimental results. That goes against everything we've talked about so far about being open-minded and being inquisitive and using the scientific method and avoiding words like fact and definite and things like that. C. All scientific explanations do not have to be based on experimental or observational evidence. If it's not based on observational or experimental evidence, how is it really a scientific explanation? Not a good answer. D. All scientific explanations are tentative and subject to changed or improved. That's going to be our best answer here. They all used to think that maggots and flies came from decaying meat. They believed that to be true, but in light of new evidence that was based on an experiment, they were able to see that spontaneous generation isn't actually a thing. Living things only come from other living things, and that was groundbreaking. So there's science. That's science in a nutshell. A lot of these questions have to do with scientific method, scientific way of thinking about things. Please review the reading in your overview. Science and the natural world. Good luck on your exam.